So here we're going to take up the results from that simulation where you connected different light bulbs in series and in parallel. So first we're going to take up your answers, your results, comparing the brightness of the light bulbs when you connected 1, 2, and 3 light bulbs in series or in parallel. So let's say when one light bulb is in the circuit, when we just have a simple circuit, we'll call that level just bright, regular brightness. Now, when you added a second light bulb in series, which means beside the light bulb that you started with, you should have noticed that each light bulb gets a little bit dimmer. When you add an additional light bulb, so you have 3 light bulbs in series now, you should notice that every single light bulb gets even dimmer. This is the dimmest the light bulbs get. In contrast, when you add 2 light bulbs in parallel, you should notice no change to the brightness. So this is the same as it was before when you just had 1 light bulb. When you add 3 light bulbs in parallel, you should again notice that there's no change to the brightness. So the brightness of each light bulb is the same as before. Now we're going to go to the concluding statements. So in conclusion, when more light bulbs are added in series to a circuit, the brightness of each light bulb will get dimmer. When more light bulbs are added in parallel to a circuit, the brightness of each light bulb will stay the same. Now we're going to relate brightness to one variable that we've already talked about in circuits, voltage. Here the statement says, the brightness of a light bulb can be related to the potential difference or voltage across it. So keeping in mind the results from your simulation, what does this tell you about the voltage across light bulbs in a series and parallel circuit? Well, this tells you that in a series circuit, as you add more and more loads, the voltage supplied by the source gets divided between the different loads. So as you add more and more loads, the voltage across each one is less than what it was when you had fewer loads. So I'll say, in conclusion, in a series circuit, as more loads are added, the voltage gets divided between each load. Now I should mention it doesn't necessarily get divided evenly. The voltage just gets split between the different loads in that circuit. Whereas in a parallel circuit, you saw that the brightness of each light bulb stayed the same regardless of the number of loads. That means that the voltage across each load stays the same as you add more loads in parallel. So in a parallel circuit, as more loads are added, the voltage stays the same. There's the results again to that blank. Fill in the blanks from your note. So here's a summary table that's actually very, very important because it's going to compare what happens to current and what happens to voltage when you have multiple loads in a circuit that are connected either in series or in parallel. So we're going to compare these results to the results of your simulation as well. So in a series circuit, when we're talking about the current, there's only one path for the current to flow in a series circuit, which means the current through each load in a series circuit is the same in every part of the circuit. Here's a quick diagram I'll draw at the very bottom. Here's a simple series circuit, one cell battery. Here's a light bulb. Here's another light bulb. Here's another light bulb. So I've got 3 light bulbs connected in series. I'll call this one R1, R2, R3, and this will be the total voltage, or the voltage from my source. In this example, there's only one path for the current to flow. That means the current at this part of my circuit is exactly the same as the current in this part of the circuit, which is exactly the same as the current in this part of the circuit. So I1, the current through light bulb 1, is the same as I2, the current through light bulb 2, which is the same as I3, the current through light bulb 3. Also in a series circuit, the voltage across each load in a series circuit is split, which means that the voltage supplied by the source is divided, not necessarily evenly, between the three loads. That means the voltage supplied by the source is actually a sum of the voltage across resistor 1 plus the voltage across resistor 2 plus the voltage across resistor 3. So you can imagine adding more and more light bulbs in series. That means the voltage across each load gets smaller and smaller and smaller as you add more and more loads. That's why the light bulbs got dimmer. Now on to a parallel circuit. In a parallel circuit, because you have multiple branches, the current through each load splits. That's a P. Splits. It's divided between the different loads. Down at the bottom, I'll draw another diagram. This one's going to be of a parallel circuit. I'll have my same single cell battery, but this time I'm going to have 3 light bulbs that are in parallel. So they're actually, each of them, connected directly across the source. I'll name them the same thing. I'll call that R1, R2, R3, and this is the total voltage, the voltage supplied by the source. In this case, let's take a look at the current. Here's the current from the battery. Once it gets to this junction, part of it's going to split. Part of it will travel through resistor 1. I'll call that I1. At this junction, it's going to split again. Part of it will travel through resistor 2, and part of it, I3, will travel through resistor 3. Notice down here, I2 and I3 are going to join up again. They're going to merge, and now we're going to have a higher current traveling through this wire. Now I1 and this current are going to join up again, and we're back to the total current passing through the battery. So in this case, the current from the source gets divided, not necessarily evenly, but it gets split between the different loads. Now back to the final statement. The voltage across each load in a parallel circuit is the same. That's why the brightness of the light bulbs never changed. If we take a look at resistor 1 or light bulb 1 is connected directly across the source, which means it has the same voltage as the voltage of the source. Same thing with resistor 2. It's connected directly across the source. So it has the same voltage as the voltage of the source. So my final statement at the bottom, the voltage supplied by the source is equal to the voltage across load 1, which is equal to the voltage across load 2, which is equal to the voltage across load 3. This page is going to be a really important page for you to bookmark or flag, because this is going to help you when you're solving problems from today. It's probably also going to help you during your open book evaluation. So make sure this is a very prominent summary page in your notes.